circuit says, consider the following circuit and answer the questions that follow. So I want us to analyze our circuit. We are given 6 volts over here, which means it is a 6 volt battery. Alright, that is our total potential difference is 6 volts. We have an ammeter over here without a reading on it. Alright, we have a voltmeter over here and a voltmeter over here. One is over the 4 ohm resistor, one is over the 2 ohm resistor. Neither of them have readings. Alright, we have 3 ammeters, one for each of the resistors. None of them have readings. And then we are given a 4 ohm resistor, 12 ohm resistor, and a 2 ohm resistor. Alright, so that is the circuit we're given. My first question says, calculate the total resistance. Calculate the total resistance in the circuit. Alright, so what formula do we use to calculate the total resistance? Yeah. So 1 over R total, 1 over R1 plus 1 over R2. Oh, supposed to be writing this in red. 1 over R total is equal to 1 over R1 plus 1 over R2 plus 1 over R3. Alright, now for all my values. It doesn't matter which one I choose to be 1, 2, and 3. I'm just going down. I can put them in any order. Alright, so that equals 1 over 4 plus 1 over 12 plus 1 over 2. Alright, so I type it into my calculator. And then type the calculator. Can someone get a calculator for me, please? Or just like lend me a calculator?
Oh wait, yes.
Let's have my nice calculator today. 12 over 6, 5 over 6. Alright, so now I've got 1 over our total is equal to 5 over 6. Now comes the important part where I swap them both. I say our total over 1 is equal to 6 over 5. Which gives me 1,2. 1,2 ohms. Never forget your units. I will come hunt you down if you do. Alright, don't forget your units. Alright, question 2 says, calculate the reading on ammeter 18. Actually, let's rather say, calculate the total current. Of the circuit. Alright, so how do I calculate the total current of my circuit? Alright, R is equal to V over I. R is equal to V over I. Importantly for my grade 10 learners, you have to start with this formula. Alright, not important for my grade 9 learners. Alright, so for my resistance I use 1,2 ohms is equal to my voltage, which I'm given 6 of my current, which is what I want to figure out. Now I say 6 divided by 1.2 gives me 5. So my current is 5 amps. Yeah. Alright, so guys, when I have a question like this, alright, I simply swap it. I swap the I and the 1.2. So I'll say, I'll insert a step over here. I'll say, I is equal to 6 over 1.2. I just swapped these two over there. Alright, so we can't do the triangle. My grade 10s are not allowed to use the triangle. Alright, here's your triangle. My grade 9s are lucky enough to be able to use the triangle. My grade 10s are not. Alright. R, I, V. Alright, so the reason why grade 10s can't use the triangle is because you always have to start with that formula. Okay. So my grade 10s, if you don't start with that formula, you lose a mark. Alright, you have to start with that formula because that's how it is on the formula sheet. Alright, grade 9s are lucky enough to be able to use that triangle. Okay, question 3. Question 3. What is the reading on voltmeter V1? Alright, so when a question starts with what is my hint that I've just been given?
Well, if you take it from the Serbian calculation.
Yeah. If it starts with, my question starts with what, that means there's no calculation involved. It's a 1-mark question. Alright, so that means I don't need to use this formula. It's the hint that I get given in the phrasing of my question. So, what is the reading on voltmeter V1? So if I'm saying what, let's use our what happens in our parallel circuits. In parallel,
And doesn't the voltage stay the same? And the current divides.
parallel V total is equal to V1 is equal to V2. Alright, so what is my reading on voltmeter 1? 6 volts. Alright, because it remains the same, 6 volts. Okay, my current, my voltage remains the same in parallel. So V1 is equal to V2 is equal to 6 volts. Alright. Question 4. Calculate the reading on A1. Calculate the readings on A1, A2, and A3. Alright, they're not going to ask you it's like this in exams, but don't feel like rewriting every single one of these questions every time. So we're going to calculate each of them. So start with A1. I say R is equal to V over I. Alright, what resistance do I use? Alright, I use my 4 ohms. Okay, so I say 4 returns 4 is equal to 6 over I, which gives me 1.5 amps. Now we'll calculate it for ammeter 2. Alright, it gets pretty repetitive pretty quickly, but that's good for revision, good for understanding. A2. Alright, R is equal to V over I. Alright, so I have my resistor is 12. 6 over I gives me a current of 0.5 amps. Alright, finally I'm going to do A3.
The answers will be there.
Yeah, so I have R is equal to V over I. Alright, so then my resistance is 2 is equal to my same voltage, 6 volts, over my current, which I need to know. So I is equal to 3 amps. Alright, so guys, now I want you to note something. Alright, so do you see if I say 1.5 plus 0.5 plus 3, it gives me 5. Right, because in parallel, alright, I total is equal to I1 plus I2. Alright. Okay, finally I'm going to add a bit of an application question for us. Question 5. What will happen to the current if I add another resistor in, if another resistor is added in parallel? Alright, so will the current increase, decrease, or remain the same if another resistor is added in parallel. Give a reason for your answer.
Decrease.
Alright, this is a 3-mark question, even for grade 10s. This is a 3-mark question. Alright, so what will happen to my current? Will it increase, decrease, or remain the same?
Decrease.
Increase. Alright, so my current will increase. Alright, and that is because my total resistance decreases. Total resistance decreases. Alright, so guys, remember when I add another resistor in parallel, my total resistance will decrease.
Why?
Alright, because let's just say I add another 3 ohm resistor. Alright, so now my formula will be, and let's pretend it's a 3 ohm resistor, so I'll add it here, plus 3 ohms. So now I'll have 1 over R total is equal to 1 over R1 plus 1 over R2 plus 1 over R3, and now we've got plus 1 over R4. So I say 1 over 4 plus 1 over 12 plus 1 over 2 plus 1 over 3. Alright, and that gives me, let me work it out.
It's 1 and 2 over 12. Or 1 and 1 over 6.
What is the resistance again?
Alright, it gives me 7 over 6. Alright, my answer is 7 over 6. So now I have 1 over R total is equal to 7 over 6. I swap them both. So I say R total over 1 is equal to 6 over 7. Alright, so now I say 6 divided by 7 gives me 0.86. 0.86 ohms. So now we can see that our resistance has decreased. Alright, there's our proof. Alright, that our resistance has decreased. Alright, you guys see that? So if my total resistance decreases, then I use my formula. R, I'll put it here. R is equal to V over I. If total resistance decreases, then current must increase. Alright. So my answer goes, total resistance decreases, therefore total current increases, and my reason is the same as last time, because resistance is inversely proportional to current, or current, I can't read that anymore, I need a marker.
No.
Alright, current, because current is inversely proportional to resistance. Right. And there's my proof for the second part. So therefore total current increases. There's my proof. Alright, any questions?
No, man.
Alright, are we happy with this part of electric circuits? No.
No, I'm sorry.
Okay.
This part.
Alright guys,